This is the second part of our lesson on refraction of light. And in this lesson, we will deal with total internal reflection and how to compute the critical angle. Now, suppose here we have two different media, medium 1 again with index of refraction n1 and medium 2 with index of refraction n2. And for this particular case, we have n1 is greater than n2, and therefore by Snell's law, angle 1 is less than angle 2. Now let us say that this is our source of light, and light will travel, or the light ray will travel from medium 1 to medium 2. Now, a very special case of refraction is when the light ray enters medium 2 perpendicularly, like this, then it doesn't bend. It just travels straight on. So that means that this is the refracted ray. And the refracted ray is also perpendicular to the boundary. Now, if the incident ray enters the second medium at an angle, like that, so this is the incident ray, and we can draw here the normal, and this is the angle of incidence, angle 1. Because of Snell's law, then angle 1 is less than angle 2, which means that the refracted ray will be somewhere here, and that the angle of refraction is greater than the angle of incidence. Also, from Snell's law, if we increase the angle of incidence, let us say this is the incident ray, and this is the normal. So now we have a larger angle of incidence. Then that means that the angle of refraction will also increase. Like that. Oops, I'm sorry. It's just the red. So that's the angle of, so that's the refracted ray. And this is the angle of refraction. Angle 2, and this is angle 1. But take note that angle 2 is greater than angle 1. And if this continues, if you increase the angle of incidence further, like this, and draw the normal here, then at some point the angle of refraction will be equal to 90 degrees. So angle 2 is equal to 90 degrees. At that point, that's the limit of refraction right there, because 90 degrees is the maximum angle of refraction. And if that's the case, then angle 1 is called the critical angle, which is defined as the largest angle of incidence for refraction to still happen. That means that if you further increase the angle of incidence, then there's no refraction anymore. What does it mean? So let us say we extend the boundary here, and let us say we increase the angle of incidence to a value greater than the critical angle. Now, because this angle right here is greater than the critical angle, and this is beyond the limit of refraction, then what will happen here is that the light ray will be reflected back to medium 1. And therefore, this angle will be equal to the angle of incidence. And this is already the law of reflection. So this is what we call total internal reflection. For an angle of incidence greater than the critical angle, refraction does not occur anymore. There will be a total internal reflection, or we can call it T.I.R. So the limit again of refraction is called the critical angle. And to compute the critical angle, we use Snell's law. If you recall from the previous video, N1 sine angle 1 is equal to N2 sine angle 2. If angle 2 is 90 degrees, then we have N1 sine critical angle is equal to N2 sine 90, which of course is 1. Therefore, the critical angle is equal to arc sine N2 over N1. Now, the critical angle between two materials or two transparent media is very specific. And in this equation, getting the critical angle, take note that this is only valid if if N1 is greater than N2. As an example, let us say medium 1 is water. So N1 is 1.33 and N2 is 1.00. So let's say medium 1 is water and medium 2 is air. Then the critical angle is equal to, well, we can compute here, the critical angle is equal to arc sine 1.00 over 1.33. So the critical angle for water to air is 48.75 degrees.